if we want to find the possible number of successes out of a certain number of trials, we have a formula now. And let's take a look at what our formula would give us for this example of 2 heads out of 5 tosses where the probability of heads was 0.4. Well, the first thing we did was we used 5C2, so math prob 3. And we took that number and we multiplied it by the probability of getting heads, which was 0.4, raised to the number of heads, which was 2, and took that number and multiplied it by the probability of getting tails, raised to the number of tails, which was 3. And we end up with this number 0.3456. Now it turns out that this type of question occurs so frequently that the calculator has a built-in command to give us this value. That command is found in the distribution menu, which is second vars, and the command is down here at A, the binom PDF, which is the binomial probability distribution function. So I'm going to select that. And the first thing we input after we select the command is the number of trials. So in this case, 5. Then we put a comma right above the 7 here. And we put the probability of success on any one trial. So the probability in this case of getting heads, which would be 0.4. And then another comma. And then the number of successes we're trying to calculate. So in this case, 2. And if I close my parentheses and hit enter, I get the same value I did by typing in the formula manually. Not bad. Now that we have this command, let's see how it can help us to answer broader problems. For example, here we have the bent coin again, and we're going to flip it 5 times. And it's the same coin, so the probability of getting heads on any one toss is 40%, or 0.4. So our first task now is going to be find all the terms in the probability distribution. So that means what's the probability of getting no heads, and the probability of getting 1, or 2, or 3, or 4, or 5. And here's where our calculator can help us out once again. We could simply repeat our binom PDF command here for all 6 possible outcomes from 0 through 5 heads. But we can also work with the functions and our lists in the calculator to shorten the process. Here's what I mean. I'm going to go into Stat and edit my list. So in my first column, what I'm going to do is put down all the possible outcomes of the number of heads in 5 tosses. So 0, 1, 2, 3, 4, and 5. It's important that we put these in the proper order. Now I'm going to go over to list 2, and I'm going to go up and highlight the L2 for list 2. And you'll see that that opens up a line down here at the bottom of the screen that allows me to input a command. And I'm going to input the binom PDF command. So second distribution, and I know it's command A, so I'm going to go up from the bottom. Past it. And I'm going to put in the notation just as before, 5 trials, comma, 0.4 probability of success, comma. Now here, for the last term, instead of putting a specific value, I'm going to tell the command to look over into the corresponding row in L1. So I need the L1 notation, which is second 1. And if I close that off, notice that this is all happening above the column in L2 or list 2. And if I hit enter, each outcome has been calculated for me from 0 heads all the way down to 5 heads. So now I have all the terms of the probability distribution. And I can actually drag that in here. Look at that. I've found all the terms in the probability distribution. So the next question asks me to show that the total of the probabilities equals 1 and explain the significance of this fact. To answer this question, we can again use our calculators to do a lot of the work for us. I could manually add up this 0.07776, 0.2592, etc., and hopefully it would come out to 1. Or I can have my calculator do this for me once again. Now, I'm going to call up my calculator again. And here, I'm going to go into my list menu again. So second, stat. And I'm going to go over to the math option. And I'll notice that this option 5 here is the sum. And all my probabilities for these various outcomes are in my L2 list. So I'm going to choose option 5. And I'm going to ask it for the sum of all the values in L2. So second 2. Close that off. And when I hit enter, look at that. The probabilities do add up to 1. Why is this significant? Well, we've detailed all the possible outcomes for tossing a bent coin 5 times, getting 0, 1, 2, 3, 4, or 5 heads. It's impossible to have any of these outcomes occur at the same time, so they're mutually exclusive. We should have a 100% chance of one of these 6 outcomes occurring. All right, our next question is to calculate the probability that the coin lands heads up at least 2 of the 5 times. Well, here's that number at least, or that phrase at least, again, which we thought about in the previous section as making us think about complementary events. At least 2 of the 5 times means I could get 2 heads, or 3 heads, or 4 heads, or 5 heads. So I could take the probability of getting 2 or 3 or 4 or 5 heads and add all of those probabilities up. But another way I could do it is to think about the complement to this. Since the complement is everything that's not included in our original event, that would be 0 heads or 1 head. So I could add up 4 values, or I could just add up 2. The 0.07776 and the 0.2592. 0.07776 plus 0.2592 to get me 0.33696. Now you may have noticed when I showed you the Binomial PDF command that there was another command directly below it. Let me show you how that works. I'm going to go back into my list, and I'm going to go over to the third column and highlight L3, and I'm going to call up that Binomial CDF command. So second vars, which is the distribution menu, and we see that right below the Binomial PDF we have Binomial CDF. So I'm going to select that command, and I'll explain what it does in just a second. Again, we're going to use the same sort of notation. So binom CDF, number of trials, 5, comma, the probability of success, which was 40%, 0.4, comma, and I'm going to have it look over again to L1, so second 1, enter. And if we look over at the values that it's filled in L3, we can see that the first one is 0.07776, just like the first row in L2. But the second row is 0.33696, which we calculated by adding the probability of 0 heads and the probability of getting 1 head out of 5. You'll notice that the next number is 0.68256, which turns out to be this 0.33696 plus 0.3456. These numbers come from adding up all the probabilities up to that number of outcomes. So you'll see that the probability of getting 5 heads or less is 100%. The probability of getting 4 heads or less is 0.98976. The probability of getting 3 heads or less is 0.91296, etc. So, if they're asking us to calculate the probability that the coin lands heads up at least 2 of the 5 times, what we would do is look at the probability of getting at least 1 head, or at most 1 head, and subtract that from 100%. So the probability of getting at most 1 head is 0.33696. So we would take 1 minus 0.33696 and end up with 0.6304 as our answer. So let's recap. What is a binomial experiment? Well, a binomial experiment is an experiment with a repeated number of trials that have 2 possible outcomes. What is a probability distribution? Well, a probability distribution is a table or a graph of the probability of all the mutually exclusive outcomes to an experiment. How is the binomial probability distribution related to the expansion of a binomial raised to a power? Well, what we saw there was that each term in a binomial expansion describes a possible outcome for a binomial experiment. What is the binomial formula for calculating the probability of a certain number of successes out of a certain number of trials? Well, that's this formula right here. The number of trials, C, number of successes, times the probability of success raised to the number of successes, times the probability of failure raised to the number of failures, which, if we write it out in notation, looks just like this. P of x equals ncx a to the x b to the n minus x, where a is the probability that event E occurs, b is the probability that event E does not occur, and x is the number of times event E occurs in n repetitions. How can we use our calculators to help us determine and graph a binomial probability or a binomial probability distribution? Well, there we saw that the binom PDF command occurs in the distribution menu, or second vars, as option A. And the notation for the binom PDF command is the number of trials, comma, the probability of success, comma, the number of successes. And we can use that either on the home screen, or we could fill out a list with the entire set of probabilities.